Welcome back to lesson U1A6, Properties of Vectors. This is video number 4, and we're going to try this problem together. I know I asked you to try on your own, but here is the solution after you've given it a try. So let's read this. A researcher has mapped out 100 square kilometers in the Atlantic Ocean. She uses a global positioning system to track the movements of a tag whale in the marked area. The researcher notes that the whale moved from a position point A to 5 to -3,1 and then to -7,4, so 3 different points. All distances are in kilometers, which means these coordinates are in kilometers. So we have to find out at what angle did the whale move through. So let's try to imagine what the situation is like here. So we're starting at some point A with coordinates 2 and 5, moving to some other point B with coordinates -3 and 1. Obviously, we are not scaling this. And then moving on to some other point C with coordinates -7 and 4. So what we are trying to find out here is at what angle did the whale move through. So since the whale started at A, went to B and then C, it means that we're looking for this angle made between AB and BC. So we're going to call this the angle theta. And now we're thinking, how can we find the angle between two sides? So we're going to use the knowledge we've accumulated about vectors to find angle theta. You know that you can use either dot or cross product. Dot product would be a more convenient way of finding angle theta because it's easier and shorter in calculations. And dot product will be used this way. So we're going to say since theta is the angle made between two vectors placed tail to tail, right? We are going to look at vectors BA and BC. So, which means that we're looking at the dot product of BA and BC, which equals the magnitude of BA, the magnitude of BC, multiplied by the cosine theta, which is the angle in between. So a few items we need to actually find at this point. First, we need to know the coordinates of vector BA and the coordinates of vector BC. We already know the coordinates of A, B, and C, though. We can use those coordinates. Based on the coordinates of BA and BC, we have to find the magnitudes. And then, based on the coordinates of BA and BC, we have to find the dot product. So step number 1, well, this was step number 1, figuring out a plan on how to find angle theta. But now we're going to put this plan to work. So number 1, we are going to determine BA and BC. Remember that BA means that A is the head, B is the tail. The coordinates will be coordinates at the head minus the coordinates at the tail. So that means that for BA, A is the head, so 2 minus -3. And for the y coordinate, 5 minus 1. Obviously, you don't have to write this step, but I'm writing because I like to explain things in this case. So 5 and 4 would be the coordinates of BA. Similarly, we'll find the coordinates of BC. So coordinates of BC, again, B is the tail, C is the head. So from the head, subtract the tail, which means that from the head, which is C, -7, subtract the tail at B, -3. So -7 minus -3. Next, 4 minus 1. So BC will have the coordinate -7 plus 3, -4. 4 minus 1 is 3. So we got BC. So based on the coordinates of the vector, now we'll focus on finding the dot product, and we're going to find the coordinates as well. So let's start off with dot product. That would be step number 2. Now the order of the steps at this point won't matter. So, but it's important we start off with finding vectors BA and BC, obviously. But now we can start with either the left or the right side. So BA dot BC means that we're multiplying 5, 4 by negative 4, 3 in a dot product, right? Because multiplication means different things in vector multiplication, right? So again, same drill, x multiplied by x, y multiplied by y. So that would make 5 times negative 4 plus 4 times 3. Okay, so that's where this comes from. And this is a 12. And then we have negative 20 plus 12 equals negative 8. That's BA dot BC. So now we know the left side, the value of the left side. We have to find the magnitudes. So for BA, that would be our step number 3. So I will write here magnitudes, right? This is the dot product, and this is the vectors, so vector coordinates. And for magnitudes, obviously, we'll refer to the coordinates of each vector. We have vector BA with coordinates 5 and 4. Forgot the vector symbol here. And vector BC, I'll write it here, with coordinates negative 4 and 3. Okay, so by the way, so BA 5, 4, and then BC negative 4, 3. That's where we get the numbers from. Now remember that the magnitude of a vector, use the absolute value, equals square root of 5 squared plus 4 squared here. That would be 25 plus 16, which is the square root of 41. For BC, we'll have the magnitude equal to negative 4 squared plus 3 squared. So that's 16 plus 9, root 25, or 5. That's a better number. And now we'd say that we're ready to find the angle. So that's our final, or our yay step. Ready now. We're going to say that to find angle theta, we're using the same formula. I'm going to rewrite this same formula one more time and show the substitutions. So here we go. This is the formula we're using. BA dot BC, we already got that, negative 8. AB is root 40, or BA in magnitude is root 41. BC's magnitude is 5, and cos theta is unknown. So we'll say cos theta, you're equal to negative 8 divided by 5 root 41. So you're isolating, and that would equal, let's calculate this. So what we have is negative 8, which divides 5 root 41. To the power of, so we're going to get a fancy decimal number. In this case, we got negative 0.2498. 78. Obviously, you're going to leave the answer in the calculator so that you get the precise answer. And you're going to take the cosine of this answer. And the answer that I got in here is, give me 1 second. So inverse cosine of negative 0.249. So I got 104.5 degrees, and I expected this because I see that the cosine ratio is negative, right? So what that means is that this angle, which, I probably didn't draw it correctly because I didn't actually plot the correct coordinates, would be an angle of 104.5 degrees. So it seems that the whale has moved this way around. So this would be the angle theta. So I hope that This made sense, and I hope that you understood the steps. One last thing before we leave is whenever you are solving a multi-step word problem, once you get to the end of it, always read through the solution one more time just to map out all the steps, because it gives you a better, more solid understanding of how you solved the process, and that will build your confidence every time you solve a new problem or a problem that you've never solved before. Thanks for watching, and see you next time.